Hi guys, welcome to my channel Leela Web Dev. In this one, we'll try to talk about something that confuses a lot of people. So, how does your CPU handle the multiple threads or process when there are fewer CPU cores than threads? So, by the end of this video, you will be able to understand exactly what going on inside your computer's brain. So, let's imagine this scenario. Let's say that I'm having let's say that we will be having 6 threads. So I can able to draw here. So let's assume, so this is our one thread and this is our second thread, third thread, fourth one, fifth one, and the last one is the sixth one. So let's say that you will be having 3 threads. So here 3 threads means, so let's assume that, so these 3 threads combinedly may be in one process. Okay, so you can assume it that these three are in one process and these are separate threads or something like that. So you can assume however you want it, you can do it. So now here what I want to do it is, so we are having these threads, right? So here we are having the threads, right? So let's try to design correctly. So I will try to take some shapes. So here I will try to use the thread something like this. Okay, sorry. So this is our single thread and I will try to do it simply. And here I can copy this one and I can paste it. So 1, 2, 3, 4, 5, 6. So these are the 6 process which is running. And let's assume that we are having the CPU core. So here we are having the 4 CPU cores. So let's assume, so this is the 4 CPU cores which you will be having. Let's keep it in a red color or something like that. And here, so this one you are having, it is the 1, 2, 3, and last one is the 4. So these are the 4 CPU cores in your thing, and we are having the 3 threads. So these are the 6 threads we are having. So now let's assume that, so now these threads could be all from one process. So this can, all threads can be one process or from 7 different process, or maybe some from one process and others from another. It doesn't matter where they come from. So the important thing is we have 6 units of execution and we are having only 4 core CPU. So now how it will be running? So normally the people has a common wrong assumption the people make. So you might think that each core will get one of its thread. Okay, so let's take this one and let's apply each core is executing the one of its thread. Okay, so this is the thread it is getting executed. So let's try to minimize this one little bit. Sorry, too much big it is. So here where we are having, so 4 different threads are executing in the 4 cores. So this one you know out. So core 1 runs the thread A. So let's assume that this is the thread A. So if you want it, you can add it thread A, and this one is thread B, and this one is thread C, and this one is thread D. So it is running. So these are the things it running, and they stay that way until it is done. So now if that was true, then first 4 threads would get 100% CPU. So this one will have the 100% CPU. So this one will be executing with 100% CPU, and this one will be executing with 100% CPU, and this one also will be executing with 100% CPU, and the last one also 100% CPU will be used. So each one will execute like this. The extra 2 threads is there, right? So they just wait, and when they start, they would share a core. So maybe they would get 50% CPU. So here what you can see, so let's say that it can be waiting for this one and it can be waiting for this one. Okay, so here you'll be having like this. So it can be in any place, so here or here, anywhere it can be. So that means, so this core will be sharing this one and this one. So here you'll be having something like 50%, and here also this one also it will be sharing 50%, and here also it will be sharing 50%, and this one also will be sharing 50%. So why? Because this one has to execute. So this one sounds logical, right? But actually what it is happening is completely wrong. In reality, modern operating systems like Windows, macOS, Linux, even those in the IoT devices, they do not stick a thread to a core permanently. So instead, a CPU scheduler works like this. So for example, let's say that, so here you are having the 6 threads, right? So let's try to move these all 6 threads to one place. Okay, so these are the 6 threads you will be having. So what will happen here? So normally the four will be assigned to here directly. Okay. So each one will be executing without any problem with 100% CPU. So the CPU scheduler will assign the time to this one. So when the time slice is over, so all the things, so here what will happen? So all the four will come into the ready state. So here let's assume that this one is the ready state, and these all will go away like this. Okay, and these all the things will be in the ready state, and remaining two are there, right? So which are in the ready state. So here it will commit like this, and the remaining two cores are idle, right? So the whichever it may be in the ready state, so it will come here and it will start like this. So now here another thread is peaked by given CPU time. The switching happens constantly. So here what will happen is the switching will be happen constantly. So the switching will be going on happening like this. So the threads are moved around. So once this time slice is over, again these two things will be moving here, and it will be in the ready state, and again these things will come. So like this. So this one will be having. So that is so you need to assume that these are all not glued to the one CPU core. So here is what for CPU usage. So how the CPU usage will be. So let's say that we have 4 cores. So we can think of it as 400% CPU power. So now it is 400% CPU power, and we have 6 threads. So that means it should be something like 400 into 6. So 400 into 6 means, so what it is, sorry, 400, not 400 into 6. So 400 divided by 6. So that is nothing but 66%. Okay. So that means here the CPU usage will be all will be sharing 66, and this one will be having 66, and this one will be having 66, and this one will be having 66, and this one also will be have 66, and this one also will have 66. So like this the CPU usage will be shared between the 6 threads. The CPU scheduler divides the available CPU time equally among them. So that is the thing. So round that up, you will see about 66% CPU usage for each thread in your system monitor. This is because only 4 threads run at each time. So here only the 4 threads can run at each time. There is nothing but parallelism, but all 6 get the CPU time by taking the turns. So this is called as an concurrency. So now we can describe our scenario like this. So we have 6 threads. So that means we have 6 threads, 1 2 3 4 5 6 6 threads running concurrently, but only 4 of them are running in parallel at any given moment. So here you need to understand this one. So we have 6 threads running concurrently, but only 4 of them are running in parallel. Now you should be able to understand the difference between concurrency and the parallel thing. Concurrency means they are all making progress. Parallelism means multiple are running at the exact same time. So that is the big difference. So if you still have this as a something confused, something like that, so you need to go back to our previous videos and you need to understand again. So that means here the final thing what I want to tell you is we have the 6 threads which are running concurrently, but only 4 threads are running in the parallel. So that is the main thing. So you can see it in the activity monitor. In the next video I will try to show you the practical implementation of this one. So we will run some threads in the terminal, watch the activity monitor, and we will see their CPU usage balancing out because they are being constantly switched between the cores. So that's it guys about this one. So now you can able to understand how the CPU scheduling really works and when you have more threads than cores. If you found this helpful, hit that like button and subscribe for more deep dives into how computers actually work. See you next time. So that's it guys about this one. Thank you.